The answer I usually get on this question is the answer I just got, which would be the same restriction on y. Well, clearly, y can't go beyond 2 on this end and 9/2 on this end, right? All the points in here would satisfy 2 less than or equal to x less than or equal to 9/2 and 2 less than or equal to y less than or equal to 9/2. But so would all the other points in the square that would be, just right here, okay? So this would be like 2 less than or equal to x less than or equal to 9/2, 2 less than or equal to y less than or equal to 9/2. That allows the point 9/2, 9/2, doesn't it? Which is clearly not in this region. Okay? So how are we going to reconcile that? Well, what we do is we say, okay, I accept this. Okay, x has to be between here and here, right? So take a typical x between here and here. What are the limits on y for that x? In other words, if you're confining yourself to this x value, you're confining yourself to this line in the xy plane, right? Or to this corresponding plane in three-dimensional space if you were interested in that, but right now we aren't, okay? We will be, okay? So right now, just confining our attention to the xy plane. If this is x, then what are the limits on y? What's y here?
Less than 9/x.
Well, you know exactly what y is at this point. What's the y coordinate of this point?
2.
Huh?
2.
2. Right. Okay, and y stays in the region until you get here. So what's the y coordinate of that point?
9/2. Or
Not 9
9
halves,
over
that'd be up
x.
here.
Yeah, 9/x.
Yeah, okay, so there it is. Okay, 2 then has to be less than or equal to y, which is less than or equal to 9/x. For any x, you're in the region if x is between 2 and 9/x. Right? So there it is. There's your region. Okay? What's the area of that region? There are 2 ways to answer. You told me when I first asked the question down here, you said, okay, that region would be described by the integral from 2 to 9/2 of 9/x dx. Okay, well that's not the region, that's the area of the region. Okay? Okay? Which is not relevant to finding this volume, okay? It would be if we wanted to find the volume of the cube above this, right? The volume of the cube above this would just be equal to the area of the region multiplied by 4. The height between 2 and 6, right? Because you'd have a cylinder. This is, it's not a cylinder. Cylinder would be bounded by a smooth curve. Anyhow, it's some sort of a prism or cylinder. Okay, it's got a constant cross-sectional area, right? The idea that I absolutely hate the formula LWH about, right? As we talked about in physics yesterday, because it obscures the fact that you're multiplying the cross-sectional area by the altitude. Okay? General principle. Well, that's what you would get if you wanted to go all the way up to the surface, to the top surface of this cube, right? You'd have a prism with this area, very easy to calculate, right? And you could easily find the volume, okay? And actually, that's kind of maybe important, all right? Maybe important for our purposes related to the quadratic function. But what we really want is the volume between here and this surface as it cuts the cube, right? So how are we going to get a hold of that? Well, it turns out to be simple. This is not immediately relevant, but it helps us visualize what's going on, okay? And we can think of this prism and stuff, and how do we modify it now if we have this surface, okay? Well, it turns out that what we do is we integrate with respect to x from 2 to 9/2, but what we integrate is another integral which goes from 2 to 9 over x with respect to y. The limits on the integral, the limits on this region, x, if x goes from 0 to 9/2, y goes then from x to 9 over x. And I said 2 to, yeah, but it does go, it goes from 2 to 9 over x. Okay? So this description gives us this integral. And what do we integrate? Well, we want to integrate how high the thing goes. Okay? And that is, maybe didn't leave myself quite enough room, but I think I can get it in. 2 squared of xy minus 2. Because for given xy point, how high do you go? Well, you go up to z equals 2 before you start counting anything, right? Before you start counting volume. And then you go from 2 up to this surface. Okay? And there's your integral. Now, I'm going to relate that to your parallelepiped, truncated parallelepiped. But that is the method, and that integral does give you the area. Okay? So we want to back off just a little bit. This is a process. Let's try to completely make sense of it, okay? See exactly why this works.